Hi guys, we're starting a new topic on exponentials and logs, and I just want to talk about the exponential and what it really is first of all. So on your calculator, if you go to your calculator, you will see a button over here which is your ln and e button. So if you do e to the power of 1 and go enter, right, we get a number of 2.718, so on. Now that number I want you to treat a little bit like pi. Okay, pi was, remember back in year 8 and 9 when you did pi was the connection between the circumference of a circle and the radius, wasn't it? Alright, so that was a ratio that you had. Well, over here, when we start looking at applications of things in nature, this particular ratio comes up all the time, which is 2.178. So this is how bacteria and that sort of stuff grow. In terms of their natural logarithm, this number keeps popping up. Now I want to graph that to show you what this particular graph looks like, and this is a little activity that we might do in class as well. So do this on my calculator, so e to the power of x, okay, and we'll just graph that. Right. Now obviously I haven't set my window up properly, so let's just change my window to -5. Make that go from -5 to 5 as well. Right, just so these things sort of centre around their origin quite well. Okay, you get this idea. That's my graph there, and you know, a really good simple thing to do then would be to look at a pattern. So if we did something like e to the power of say 3x and graph that. So it looks fairly similar, it just makes the graph steeper, doesn't it? Alright, and then we could try one where we have something like, let's try one where we've got e to a fraction. So let's go e to the 0.2x. Alright, and see what that looks like. And we'll graph that as well. Alright, and so you can see that's obviously less steep. Now, on this side over here, you can see that the graph's getting close to 0 there, isn't it? As it goes off to negative infinity, it's getting close to 0, but it's coming from above. It actually, this line here, the x-axis is in fact an asymptote line. Notice all of these things go through 1, don't they? Now, you might say, what happens if I have a minus e, or e to the power of a minus? Well, let's try that. And we can just build up, and so this is the good thing about having a graphics calculator, is you can play around with these things and look for yourself. So if you forget, I mean, you still find out by just having a look at the patterns. E to the minus x, and we graph that. It's exactly the same sort of graph, but it's going down that way, and it's obviously going to positive infinity over there. Alright, so that's giving us a little bit of an idea about what the function is. And we talk about, obviously, when we start looking at that, e to the power of 2.718 is what e is. I mean, you don't need to remember that. Rather than writing that big number down, which is an irrational number, it's simply easy to just use e, and that's why we use e, right? Again, if we compare that to pi, instead of writing 3.14 blah 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 down, then what we do is we write pi. Now, remembering, I mean, I had a student a couple of years ago who actually learnt pi to 100 decimal places, and he actually failed Year 12 maths. I mean, I think it's about remembering information that's really important, isn't it? So what we can say is f of x is equal to e to the x, okay, f dashed of x, and we'll be looking at this in future videos. The derivative is simply e to the x. Alright, so I don't want you to get frightened by it. I think when you start doing the derivatives for these things, I think you'll find them actually easier than what you've been doing before, because it's pretty straightforward in terms of what it has to be. Alright, so, and then we'll start looking at doing the same thing we've done in the previous lot of calculus. So this will be a little bit of review of what we've already done. And so we'll be using things like the product rule, the quotient rule, and the function of a function rule, and all that sort of stuff. So it's a good chance to do a bit of a refresher of what we did with calculus, but now we can once we start introducing E, we can start looking at things that are simply more realistic in terms of real life applications. All right, so treat this with a headset, which is, I'm going to review what I've already done. I'm not frightened about this thing called E. It's just a number that's got lots of decimal places, and so therefore I'm going to use this terminology with that. All right, so we'll have a look at doing the derivatives in the next video.